So this will continue through chapter 10 with counting methods. 10.3 gets into what we call permutations and combinations. So we've kind of been touching on this as we've been going along, but we're now going to get more into the actual formulas. We're also going to show you a few things on the calculator that can also be beneficial to you. So again, you should see that TI-84 link in your Unit 2 folder. Feel free to use it and see if you can model some of the things I'm doing with my TI-84 calculator. So working with permutations to start with. So a permutation is an arrangement of objects in a specific order. If the orders if the order matters, then you're dealing with a permutation. So so again, we're getting into these arrangements. And like I said, we're trying to count how many different arrangements there are. So with formulas, we're not actually identifying the what's in the actual set, just how many are in the set. So how many different arrangements there are. So we're not going to list what's in the set. We're just going to count how many is in the set. That's what we call counting methods. So the main idea with the permutation is if you change the order, that creates what we call a different permutation or arrangement. So if I give you ABC, ACB, and BAC are actually different. So in this case, the order is important. So order matters. So if we're dealing with a permutation, we'll pick up on that. So counting permutations, if there's an indistinct objects and we choose all of those objects, the different ways of arranging it is what we call n factorial. So we've kind of done this before already. So n factorial counts the different arrangements if order matters. Now, getting into another type of permutation is when we don't choose all n objects. Suppose we just choose k from n. So we don't choose all of them. We just choose a subset out of that. So there's a formula for a permutation where n represents the total number of items in our set, and we're only choosing so many of those, where k is how many we're actually choosing. So how many ways can we arrange k out of n? So notice how we have this formula that's actually the permutation formula, n factorial over n minus k factorial. So this formula can be found on the calculator, and some calculators are different. So yours may be a little different than mine, but I'll show you how mine works. So in your homework, you may be asked to evaluate a permutation. So I have 8 items and I want to just choose 2 of them. So what that means is if I'm using the formula, our formula says that we're going to have this n factorial over this n minus k factorial. So notice how there's k or r. I think some of our stuff is actually using r for the choice, but it could be anything. So here they're using n and k, where k is how many I'm choosing. So remember, one way of doing it is to simply say, I'm choosing 2, so that's just really going to just be 8 and then times 7, which would be 56. Now, if I use the formula in the calculator for a permutation, if I go to math, go to probability, you'll see this NPR. So NPR is going to be similar to this NPK thing that we had here. So they're just saying N choose R, if you will. That's our permutation. So what they're saying is how many different arrangements are there if order does matter. Now, the way my calculator works, if I choose this, number 2, what I could do is put in the 8 in front. Maybe just that make that a little bit bigger for you. So 8, let me just clear this up again and try that again for you. So I can go to math, go to probability, number two. I can then fill 8 in and fill the 2 in. I can actually put that into the calculator and it understands the formula, which would give us the 56. So that's how I could think of it using logic or just substitute into the formula. So again, I could also just do the formula by hand where I have 8 factorial over 8 minus 2 factorial. Notice how it's going to be 8 factorial over 6 factorial. But notice that 8 factorial is going to be the same thing as 8 times 7 times 6 factorial over 6 factorial. Notice how the 6 factorials cancel out, and you would still get back to 8 times 7 is 56. So we have that going on there. So when to use a permutation? Again, use a permutation when order matters. You're making arrangements. You're forming ordered lists, codes, or lineups. Positions matter. First, second, and third, those orders matter. So positioning matters. So assigning medals like the gold, silver, and bronze in the upcoming Olympics. Seating people in rows. Creating passwords without repetition. Arranging letters in a word. Again, the same thing without repetition. Now, there can be permutations with repetition, which is not going to be a factorial formula. So if repetition is allowed, remember how we did this problem earlier, a 4-digit pin, 0 through 9. Notice how each position there was 10 choices. So 10 to the fourth, there would be 10,000 different arrangements. So notice how, again, this is not a factorial situation. So the permutations we're referring to is going to be mainly without repetition. But we have done some that are with repetition, but they're not going to fit into the factorial formula up here.